A very good morning, students. Myself, Sagar Kumar, and today I'm going to discuss with you the Sp3 hybridization in Organic Chemistry 1 of B.Pharm first year. So, in today's lecture, we are going to discuss the hybridization first, and then we will discuss the Sp3 hybridization in alkanes. So, what is the hybridization? Hybridization is actually intermixing of atomic orbitals and then redistributions of these orbitals to form new identical orbitals. So in hybridization, what the carbon does, carbon intermix its s orbital with p orbital and then redistribute its orbital and give the new hybrid orbitals which are identical in every aspect. So this is hybridization, simply intermixing of atomic orbitals and then redistribution of these orbitals to give the new hybrid orbitals which are identical in all the aspects, so that the carbon can form the bond with the other carbon atom or with other atoms which are identical. Okay, so carbon can undergo different type of hybridization. It can undergo sp3 hybridization, it can undergo sp2 hybridization, and it can undergo sp hybridization. In today's lecture we are going to discuss the sp3 hybridization. So we will begin with sp3 hybridization. What is sp3 hybridization? So if I simplify this sp3 hybridization, you can simply say, by looking at the sp3, it's saying that one s orbital is involved and three p orbitals are involved in hybridization process. So the name is given sp3. One s orbital of carbon is involved in hybridization and three p orbitals of carbon is involved in the hybridization, and this hybridization will give the four new orbitals which will known as sp3 hybrid orbitals, and these hybrid orbital will have the identical properties. So to understand the sp3 hybridization, first we have to discuss about the electronic configuration of carbon. So if I draw the electronic configuration of carbon in ground state, it will be like that: 1s2, then in second shell it has 2 electron in s orbital, then it has 3 p orbitals in second shell, that is 2px, 2py, and 2pz. So it has one electron in 2px and one electron in 2py. ठीक है. So it is the ground state of carbon. When carbon undergoes for the bonding, it goes into the excited state. So in excited state, the electronic configuration becomes, just before the hybridization, it becomes 1s2, and this electron from second shell s orbital gets shifted to the p orbital. So the electron in second s becomes just 1, and 2p have its one electron, 2py has its one electron, and 2pz get one electron which is shifted from the second s orbital to the 2pz orbital. So if we look at this configuration, the configuration of excited state of carbon, This is the excited state of carbon atom. If this configuration is really involved in bonding procedure, then in the alkane we will have the bond of different properties, because if this excited state is involved in the bonding procedure, the one bond is formed with the overlapping of s orbital and three bond is formed with the overlapping of p orbitals. P orbitals have different shape, different energy, and s orbital have different shape and different energy. So the bond will be different in properties in case of alkane if this excited state is actually involved in the bonding procedure. But in practical, all the bonds in alkane are identical, especially in methane. If we discuss about all the four bonds of carbon with four hydrogens, all the four bonds are identical in all the properties. They are not different at all. But if we go through this excited state configuration, it says that the carbon should have different type of bonds in alkane, which is not true. So what happens? Here comes the hybridization. Once the carbon gets into the excited state, then this carbon atom goes into the hybridization process. So what happens in the hybridization process? What happens in hybridization process? The carbon mix its 2s orbital and these three p orbitals. I am drawing the excited state configuration right now, and the 2pz. This is the excited state configuration. But when it goes into the hybridization, what happens? This s orbital, the one of s orbital, that is 2s, and 3 2px, 2py, and 2pz. These three p orbitals and this one s orbital, that is second s, is got intermix and get redistributed. It means it undergoes the process of hybridization, and by this process these orbitals form four new hybrid orbitals, which is known as sp3 hybrid orbitals. So after hybridization, what happens in carbon atom? The configuration becomes 1s2. Now because these all four orbitals got hybridized, so the new orbital is known as sp3 hybrid orbital. Okay, so it forms four new sp3 hybrid orbital. So this form sp3 hybrid orbitals, and these sp3 hybrid orbitals are identical in properties. They have same energy, they have same geometry, they have same electronic density. In fact, they have all the identical properties. They are not differ from each other either in shape or in energy. They are just identical in every aspect. So we have four sp3 hybrid orbital. So I can show them like this. We have 4 sp3 hybrid orbitals, and each of the hybrid orbital have one electron in it, that is like this. So we have 4 new sp3 hybrid orbitals which are identical in shape and in energy. So when this sp3 hybridized carbon atom goes into the bonding procedure with hydrogen atoms in case of methane, what will happen? Now if I draw the orbital structure of hybridized carbon atom, I can draw it like this, that this carbon, it has 4 sp3 hybridized orbitals, that is one like this, second like this, third like this, and fourth like this. And these sp3 hybrid orbitals, these all are sp3 hybrid orbitals, sp3 hybrid orbitals. And these sp3 hybrid orbitals get overlapped with s orbital of hydrogen atom. So here we have the s orbital of hydrogen atom, s orbital of hydrogen atom, and s orbital of hydrogen atom. So in case of methane, all the 4 bonds between the carbon and hydrogen are formed by the overlapping of sp3 hybrid orbital of carbon and s orbital of hydrogen. And these all 4 bonds are identical in bond angle and identical in bond length. Okay, so the bond angle will be, the bond angle will be 109 degree and 28 minutes, and the bond length is 109.08 angstrom. So all the 4 bonds are identical in bond angle and identical in bond length because of sp3 hybridization. Because carbon have 4 sp3 hybrid orbitals in case of alkane, and these hybrid orbitals get overlapped with s orbital of hydrogen in case of methane, and all the 4 sigma bonds which are formed are identical in properties. So this is the sp3 hybridization which is involved in alkane. sp3 hybridization is used by the carbon where it has to form all the sigma bonds, or where it has to fulfill its valency by the formation of sigma bonds completely, as in case of alkane. But in case of alkene, hybridization will be different, that will be sp2 hybridization, and in case of alkyne the hybridization will be sp hybridization. If I discuss about the geometry of sp3 hybridization, the geometry of this molecule will be tetrahedral, which is different from the geometry of sp2 hybridized carbon atom molecule. That is in case of alkene. In alkene we have trigonal geometry. So this is all for the sp3 hybridization in alkane. In next lecture we will discuss about the sp2 hybridization in alkene, sp2 hybridization of carbon atom in alkene. So this is all for today's lecture. Signing out and thank you very much.